All right. Well, here we go. Welcome, everyone. We'll give the stream a minute to let everyone make it into the chat here. And yeah, looks like we got a few people rolling in. How's everybody enjoying the show today? That build video from Ape that just finished up was pretty awesome. That looks like a pretty sweet kit and nice setup for an end-fed half wave. So looking forward to building that one at some point. Pretty cool setup, and I'm also really looking forward to those ribs that Frank's making. I hope hope he's willing to send some out this way. So let me bring my guest in. Hayden, welcome.
Hello.
Just
How are
throw you right in there, buddy. How are you
That's all
doing?
right.
It's what, 2:30 in the morning there in Tasmania?
It is 2:30 in the morning, yeah. But I was really interested in this topic, so I wanted to join in and have a chat about it on the stream today. So looking forward to it.
Cool. Well, it looks like we've got a crowd growing here, so we'll kick things off. Just a quick introduction for any of you that aren't familiar with my channel. I'm Adam, K6ARK, and I have a YouTube channel where I film my adventures in the hills for Summits on the Air and lots of other build videos for antennas and kits and such. And one of my favorite aspects of working Summits on the Air is to try to get DX stations in the log from the summits. So I experiment with different antennas to achieve that. But also, I've come across a tool that has become really useful in helping to predict propagation and figure out what time of day to be on a summit, what band to be on, and what antenna to use to maximize my chance of success. And that's what this stream is all about. So as I said, if you have any questions, throw them into the chat, and Hayden's going to help me keep track of them. But one of the first things I want to do is show a clip of a video of a contact I made from a summit in Southern California to Hayden in Tasmania on 15 meters a few months ago. So let's get that playing.
Hello CQ 15 meters. This is Kilo 6 Alpha Romeo Kilo calling CQ and standing by for calls. Victor Kilo 7 Hotel VK7HH. VK7HH from Kilo 6 Alpha Romeo Kilo. Kilo 6 Alpha Romeo Kilo. Roger, I copy 4-1. You are 4242 42 QSL?
QSL 42, thanks Adam, 42, got you there. Come out of the noise.
Awesome, yay, we did it. Very cool. Thank you in 7-3, thank you in 7-3.
Roger, 73, thanks Adam.
Woohoo! We got Hayden, that was awesome.
So there you go. That was our successful sideband contact on 15 meters. I was operating from a SoCal summit. And tell us about your massive DX capable station down there, Hayden. What we're using on that end?
Well, I was only using an ICOM IC 7300 and 100 watts, and I would have been. That would have been the DX Commander I was running off the vertical.
No,
so
it was before that. I think it was your end-fed half wave. Yeah.
Oh, yeah. I was trying to think. It might have been. So yeah, nothing too special, and that was just strung up in a tree that wasn't very high. But I noticed when I first started to call, I wasn't very strong, and we had a little bit of a peak there as well, where I got quite strong. It was quite easy to understand what I was saying. So. Yeah, the band conditions were sort of really up and down that day, weren't they?
They were, and when you're working a marginal contact like that, you kind of just have to have a little bit of luck and timing, and have to be able to work the system there. So the noise level where I was obviously was very low, being out in the wilderness on a summit. But how's your noise at your QTH?
Yeah, Don just asked that in the chat as well. On 15 meters, it's not too bad. It's relatively quiet, but I probably would have been averaging maybe an S1 to an S2 noise level. I had no problems hearing you, though. I could hear you fine. So it was quite easy to copy you. But one thing that I know that you were, the signals were not overly strong, so that's why I gave my signal report several times to make sure that you copied. And obviously, during one of those peaks, I come out of the noise there, and you could copy it quite easily. So that's, I suppose, a little bit of a tip for those who might be just starting to. If you're working the DX and it's not quite there, just keep repeating your signal report and over and over, and eventually someone will get it. So.
Absolutely. Yeah. And so the antenna on my end, I was running 100 watts with the Yaesu FT857. And the antenna I was using is what I call a double bobtail. It's basically two bobtail curtains. And I actually have a video on that. So if you search my channel for the double bobtail video, you'll find that whole video and a discussion on the antenna. But it gives me some directionality, a pretty low angle of radiation, and a bit of gain. And I had it, broadside pointed in your direction for that, because we were planning to try to make that contact. And that leads us into the tool that I use to help us plan that contact. So the tool is a website that's makes a simple graphical user interface version of a piece of software that's been developed over quite a number of years with a ton of data collected, as far as propagation information goes. The website is called VOACAP, and it stands for Voice of America Coverage Analysis Program. And it's had a variety of military-based and educational institution-based research and support. And the product now is pretty incredible. So my goal today is to give you all a bit of a walkthrough of how to use this system, how you can familiarize yourself with it and start using it to maximize your chances for DX. So this is the initial page that you reach when you go to voacap.com, and you'll see these kind of pretty plots down here. 3 of these links just go to the same page, and we'll load that up here in a second. There are a whole bunch more links down at the bottom from a variety of sources that can give you a ton of additional information, but we're not going to dive into that stuff today. I want to go to these main links at the top here and give you an introduction to the page. So when you load the page through one of those chart links, it loads this map page, and this is where you enter a wide variety of information that you can use to set up your propagation prediction. So I'm going to walk through the different controls on the chart here. First things first, you can drag and drop these pins on the map to set your transmit and expected receive locations. Generally speaking, this website is a tool for measuring point-to-point propagation predictions. So rather than trying to find a coverage area map, which you can also do, it is mostly focused on point-to-point prediction. So if there's a DX entity or a station in Tasmania, perhaps, that you want to make contact with, this is a great tool to be able to do that. So for our example, I'm going to drag the receiving station down to Hayden's QTH. And one of the odd things you'll notice on this map, and this is a little quirk, is that as you cross the international date line, the cursor disappears. So you have to look over to the right side of the page where it appears again. And I'm just going to generally drop it down in the vicinity of Tasmania there. I don't know where exactly you are, but
it's pretty close.
It's close enough.
Yeah.
For the purposes of this website, you don't have to be exact. So, so I've placed the points on the map, and then I need to go through and check the rest of these settings first. So I'm going to run through the controls on the map here. In the upper left corner, we've got just a zoom in and zoom out button. And then we can also go full screen on this if we want to, which hides some buttons at the bottom, but makes it pretty easy to use the page here. Right below that is a button to show QSO window markers. This basically lets you preset a variety of areas. I don't typically use that. I typically just use the drag and drop method with the two primary cursors. You can use this button with the circle and the dot in the middle to save your settings for future use when you come back to the site. And then you can use the button right below it to remove those settings. The button below that, the SP, switches between short path and long path calculations. So depending on which you'd like to try to calculate, typically speaking, short path is going to be much easier than long path. So we usually leave it on short path. And then you can choose to use the sporadic E layer in calculations if you'd like, but I have not experimented with that much, and I don't know how reliable it is. It probably just uses data based on how frequent sporadic E pops up and contributes to longer distance propagation. Up in the upper right-hand corner, you have a drop down to set your mode that you're using. And those modes give the system inputs as far as necessary signal to noise ratios. Basically, what is the weakest signal to noise ratio that a given mode can reliably handle? So I'm going to stick with, well, let's go to single sideband for our contact. You can choose the transmit power from well, a wide variety of sources here, and well above legal limit for ham radio, but perhaps limits for other other broadcast sources. And then the antennas page, when you click on the button for antennas, it slides in this page from the left-hand side here, and you can select what type of antenna you're using. So there are a wide variety of pre-existing selections in here. So I'm going to go through and put a quarter wave vertical with good ground for the receiving end, since you've got the DX commander now, and that's what your antenna functions as. Let's see here. So we'll select that for all the bands there. And then for the transmitting end, I simply selected a dipole at 10 meters above ground, because that's a pretty good representation of what I typically use on a summit. There is no option for a double bobtail antenna in here, not surprisingly, but using a dipole at least gives me a good reference to start from. So I'll stick with those settings for now, and to make that page hide again, you simply click the antennas button once again. And some more settings. The button under antennas over there slides in the settings pane, and this is where you enter your local noise level. So you can choose from noisy down to a remote location, which is pretty much no noise. So for a SOTA summit, I would typically select quiet. For an average home QTH, I'd probably select something in the residential to industrial range as the noise floor. So we'll stick with quiet for now. You can manually enter a sunspot number, and one of the things that you want to be cautious with in this selection is that it needs to be a monthly average sunspot number. If you simply enter the current sunspot number, it's going to throw off your calculations. The average is much more meaningful in these propagation predictions. So the default in here is -1, and from what I understand, -1 basically tells the system to go and get its propagation, or I'm sorry, its sunspot number from an existing source, and it sort of automates the process for you. Method of calculation, I leave that on auto. The default takeoff angle selection here is 3 degrees as the minimum takeoff angle. If you set that lower, you can get sort of erroneous data because takeoff angles lower than that in a typical amateur radio setup are just not realistic. And then for some of the coverage area map plots, you can select what band, time of day, and time range you want to use. We'll talk about that a little bit later. So, and these other settings are useful in some of the other more specific plots, but I'm going to skip those for now. So close up the settings here. Are any questions from you, Hayden, or from anyone in the chat yet?
No, it doesn't seem to be any questions. I'm quite keen to see what results it pops up.
Cool. All right. So two of the key tools that I end up using are these propagation charts, this button right below the settings here, and the propagation wheel. So let's talk a little bit about the propagation chart here. I'm just going to zoom in on this so you guys can see it a little bit better. And these charts have, you can select a variety of charts from this, and some of the ones I typically use for predicting and scheduling a contact like ours is the reliability short path. That's this top selection from this list. So given our current sunspot numbers, the antennas we selected, if I was on a summit with a dipole and you were at home with your DX commander, this plot helps us understand the probability of being able to make a contact using each band at any time of the day. So on the x-axis across the chart, the bottom of the chart here is UTC time. And we are what, about 1630 UTC. So we're right in this vicinity right now. So really with our antennas on any band, the probability of success would be pretty darn low at this point. If we wanted our best chance of success, so the highest probability on this chart, that would be around 700 UTC on the 20-meter band. So you can kind of see how you can look through this plot, and again, this takes those inputs that you put into the antennas and the settings, and creates this custom prediction for you. If you change, yeah, go ahead.
Sorry, Justin has a question listed on antennas. If he's using a different antenna that isn't listed, so like a full wave loop, what antenna selection should he go with?
Yeah, so for a full wave loop, I would probably start with something like a dipole. Although if you're using a larger loop on a higher band, you're going to get some lobes of gain in various directions. But generally speaking, the takeoff angle is going to be pretty similar to a dipole for height above ground. So it's a horizontal antenna, and I would pick a horizontal antenna to use as a comparable model. Just know that your full wave loop may have a bit more gain, just like a larger doublet would on some of the higher bands, so long as those lobes happen to be pointing in the direction you want them to point. That was a good question. I think there are advanced ways to build custom parameters for antennas into this system, but not on the web-based version. There is a downloadable software-based version for both Windows and I think Linux as well. But it doesn't make the simple, pretty plots, and the data is mostly numeric and a bit harder for me to process. This online system makes it very easy for me to pop into the website, enter some parameters, and get a clear understanding of what band and time of day is going to be my best chance for a contact.
What sort of percentage have you found that seems to be consistent with results that you found? So sort of, I know that it's only a relative percentage and it all depends, of course, on conditions and things, but have you seen any sort of pattern with doing a prediction and then it tells you that it's going to be X amount of percent likely and then it happens, or the other way around, or something like that?
Yeah, the conditions change rapidly, and the calculations that this system performs are generally monthly averages. And when you're relying on those monthly averages, some days are better, some days are worse. You may have a solar storm, kick up that just knocks propagation down. So these percentages are, I think, a good estimate of what percentage of the days in the month you'd be successful in making that contact. So if it's 90%, then if all those other parameters are correct, then you could probably make that contact 26 or 27 out of 30 days in the month. So that's kind of a way that I look at it. Yeah, I can definitely show how antenna choice affects this. So let's see here. If I change,
and I just answered the question from Tom there, who talks about would you go lower or higher in power on the site if you use a different power setting on your transceiver? And I just sort of said that I guess with this case you'd use the highest power that you plan on using, and then scale back the relative percentage of chance of a contact from there, because obviously lower power is going to have a lower chance of getting through.
Right. Absolutely. So I opened the antennas page back up, and instead of a dipole at 33 feet, let's select a 3-element Yagi on 20 meters at 30 meters, or roughly 100 feet. And let's see what that does for us. Let's see here. So you can see how that significantly increased our probability of success on 20 meters, pushing us up from, I think it was around 50-something%. Yeah, up to 68%. So those make a difference. And there are some other plots that can help out as well. So I'm going to leave the antenna settings the same and show you a couple of other plots in here. This is the signal dBW, or decibels relative to 1 watt of power. That can give you kind of a similar estimate or understanding of the receiving station's S meter reading when receiving that signal. And then the other somewhat useful plot is to see the maximum usable frequency and what the probability is that the maximum usable frequency will be above that band, or that band will be within the usable frequency range at that time of day. This doesn't consider lowest usable frequency, but basically you can see that, well, for example, 10 meters around 400 UTC has a 6% chance of being within the maximum usable frequency at that time of day. Now, that doesn't mean you won't be able to use that band or that frequency for your contact, but when you're above the maximum usable frequency, your odds definitely go significantly down. So again, these reliability plots are the key ones that I end up using. I want to show you another one here that is a really useful tool. The propagation wheel gives you a similar bit of data, but in a different graphical representation. So each ring is a band, and then each pie slice of the ring is a UTC time of day. So you can kind of see how the propagation shifts across the different bands as you progress through the day. So initially around 500 UTC, the propagation is actually pretty good on 15, 17, and 20. So any of those bands would work fairly well. And then as the day progresses, it shifts down a bit into the 20-meter band as the highest reliability or highest probability band for success. So so that gives you, a look at the propagation chart and the propagation wheel. I want to show you one more thing here. Let me get out of full screen and zoom out slightly, because there are a whole bunch of buttons across the bottom of the page here. And some of those buttons have some additional information that you can't find in those plots. And I want to point out some of that. So I do see a question there. How many times did you have to schedule before success? I think we tried maybe once or twice previously. I can't remember, but we were.
Yeah, for our contact, it was maybe only once or twice, and we were successful. I think you went out on a summit. The first time we tried and we couldn't hear each other, but you worked plenty of other stations. But definitely the second time you went out with the bobtail, we made contact easily. So
Right.
well,
Yeah.
easily, but we made it.
We made it.
Yeah.
So I want to show you a few of these kind of key buttons that I use across the bottom of the screen here. The band by band button basically gives you all of those charts that we kind of just looked at, and a few others on one page. So it kind of just does all the calculations, and then you can look through these. And this one in the upper left corner is very similar to that pie chart that I showed earlier. It gives you kind of the same information, but in a grid format rather than the pie format. And that one is quite useful. I use that one often. And if you mouse over any of the blocks there, it shows you the reliability of the circuit, the signal strength, and the percentage likelihood that it will be that band will be within the maximum usable frequency. So it gives you a whole bunch of information in one shot there. You can also look at the long path plot here. So if we wanted to try to work long path, you can see that our odds would be pretty slim with this setup. And as we scroll down, these plots probably look familiar. Those are some of those other ones that we could have selected from that main page down that list. And you can even select or view different parameters for a specific band on one of those charts as well. So this is a kind of just a nice summary page with all the plots in one place. One other one I want to point out and show to you that I use to kind of help select the antenna I'm going to use is this takeoff angle page. So as that loads, we're coming up on the end of the half-hour stream here. So if anyone has any questions, please do pop them into the chat, and we'll try to address them before we move on to the next stream.
I think there's a few that have said that they're going to go back and rewatch this to go and have a bit of a play with the software. It seems like a good thing to experiment with.
Yeah, and that's this was a lot of information to go through in a 30-minute stream. Mm-hmm. So definitely go back. The link is in the description to the VOACAP page. Check it out and play along and tinker with the settings as you work through it. So this takeoff angle analyzer. One of the things I don't fully understand on this page is what the left y-axis means, this count here. But each of these plots is a given band, 80 meters, 60 meters, 40 meters, 30 meters, 20 meters. And this gives you an idea. It plots the antenna gain at a given takeoff angle. And I think the count axis, the blue bars, give you a representation of sort of how good that takeoff angle is for that contact. So you can see on the 20 meter band, those blue bars are real heavy in the 6 to 10 degree takeoff angle range. And that's, if you can get your antenna gain in that vicinity, you're going to have the greatest chance of success. And you've probably heard Callum talk about takeoff angle and how that 5 to 10 degree range is really what matters for DX. And he's right. That's what all this stuff shows. The red line on there, again, shows your antenna gain in those vicinities. So if I know the 20 meter band is my best chance for success, and I have a couple of options of antennas, I might look at the antenna model for each of those antennas and see which one gives me the best gain at the right takeoff angle to be able to make the contact on that band. Does that make a little bit of sense, I hope?
Yeah.
So these plots can help you with that. So I think that kind of sums up the key things that I wanted to show here. I pinned the playlist to the top of the chat there. And I hope that you all will take the opportunity to play with VOACAP and use it to help predict your next big DX contact, because it's a heck of a lot of fun. So let's see here. Take a quick look at the chat. Don't see any other questions there.
Very quick question. Has the tool made you more successful in contacts all over?
It absolutely has. I've had some SOTA summits where I've activated and, you know, made, like 20 plus DX contacts to, well, I think 17 to Australia, 4 to Japan, 7 to New Zealand, all on one SOTA activation, because I picked the right time of day, the right antenna, and pointed it the right direction, and just had a blast up there. So yes, it has most definitely made me more successful in my activations. So, all right,
cool.
Well, Hayden, thank you again for joining me on the stream today, even at 3 in the morning in Tasmania.
I'll be back up in another hour and a half. It's all good.
I appreciate it. So next up, we've got Frank. I think he's putting the ribs on the smoker, or perhaps they're already on the smoker. I guess we will find out. But go over and take a look at Frank's stream. Just posted the link directly to the stream in the chat. 7-3. Thanks for coming along, and we'll hopefully catch you in the log from the SOTA Summit tomorrow. 7-3, everybody.
7-3.